A virtual node, or VNode, represents an element in the virtual DOM. Each VNode contains the type of the element, a unique key for identification, properties or attributes of the element, and its child nodes. This streamlines the process of creating a virtual representation of the DOM tree. The diff function starts by checking if there's no corresponding old virtual node. In such a case, the new virtual node needs to be created on the real DOM. This scenario occurs when a completely new element is introduced into the virtual DOM tree. Text nodes are treated as string or number types in a virtual DOM. The diffing algorithm checks if the new node is text and differs from the old one. If it does, the old text node content is replaced with the new one in the actual DOM, ensuring text updates are efficient. When the types of the old and new VNodes differ, it signifies a change in the type of element. In this case, the old element is completely replaced with the new element on the actual DOM. This action can have a higher cost, as replacing elements is more expensive than updating them. If the VNode types are identical, we first update the element's attributes or properties. This involves comparing the old props with the new props and applying any differences directly to the real DOM element to reflect these changes without reconstructing the entire element. In update props function, we start by removing any attributes that existed on the old element but are not present on the new element. After cleanup, we loop through the new properties, setting each one on the real DOM element when a property is either new or has changed. With properties updated, the diff function then moves on to comparing children nodes. This is where recursion comes into play, as each child pair will also go through a diffing process. This ensures that updates are applied to every level of the DOM tree. Inside the diff children function, we compute the maximum length between the old and the new children arrays to ensure all children are visited. We then iterate over each child, comparing the old and new versions, applying the diff function to each pair recursively. This thorough process ensures that only the parts of the DOM that have changed will get updated, achieving optimal performance.